Hey, this is Don from Padlock Technologies here with another whiteboard video. So we're going to talk about MPLS real quick. And the question I always pose to people is MPLS secure? Now, most people think MPLS is secure, and it's not, right? So let's start off with the question, is MPLS secure? The answer is no, in a nutshell, right? Now, the purpose of MPLS, we're just going to talk about L3 VPNs. We're not going to talk about L2 VPNs, any of that. We're just going to talk about L3 VPNs. So, L3 VPNs, in terms of security, is a traffic separation thing. And how do you achieve that separation? Well, you're going to achieve that separation basically through VRF tables. VRF tables and um, we'll just say route target values, right? In a nutshell, right? Now I can get into the whole how MPLS is made up and all that good stuff, but I don't want to get into that. I might make another video for that. But from a security standpoint, and I use the quotes here, you have a separate VRF table, and then you have separate RT values that ultimately get placed in the VPN v4 table or v6, depending on what you got, right? VPN v4 or v6. Now, that doesn't mean it's secure. If someone was to, and the likelihood of this happening is pretty low, but again, we're talking about security, not the likelihood of a threat happening, but is there a threat, right? So there is a threat in MPLS. So if you look at, let's just say MPLS. So let's say PE here. We have another PE here. And then I'll just put the cloud as the MPLS, right? And then you have your CEs and CEs. Well, from a traffic separation standpoint, if I had separate VRFs, which I will just use different colors to say different VRFs, technically these three VRFs can't see each other's routing table. Why? Because it's a separate routing table, virtual routing and forwarding instance. That's what the whole purpose of a VRF is called. And this is separate from the global routing table. Now, the security aspect of it comes into play when we pop out of the MPLS tunnel, and it is technically a tunnel. When you pop out of that, it's clear text, right? So if I was a bad guy, I will use red for the bad guy, and I was to, Wireshark here, say bad guy here. If I was the Wireshark, when it pops out of the MPLS cloud or pops out the PE, I can actually see that data live. I can see what you're actually doing. I can see all of it, right? That's why MPLS is not as secure. Now, in the cloud or the MPLS cloud, we're going to see these separate VRF tables from a traffic separation standpoint. So the routing tables, the P routers know nothing about any of the routes, right? So this is just going to be a VPN emulation over the cloud, right? Because the P routers don't really know anything about the CE routes. They only know how to get to the PEs. MPLS, in a nutshell, is just a PE to PE transport technology. That's really all it is. Now, back to what the secure standpoint, from the security standpoint, I can still, all the data is still clear text. So if anybody tells you MPLS is secure and, not, it's a fail safe, nothing can happen to it, that's not true. So how do you fix this problem? Well, how you fix this problem is you do IPsec tunnels from CE to CE. So over the MPLS cloud, we're going to have an IPsec tunnel. Now, trying to do this individually is going to be an administrative nightmare. So every time you add a new site, a new CE, you're going to have to create another phase 1 and phase 2 in all the sites. Now, what Cisco did is they created a technology that is a VPN technology that can tackle this. Now, there is still a single point of failure or an attack point in this technology, but this handles the encryption between CE and CE, right? Now, if you don't own the CE, you can't do this, or your service provider has to offer this as a service. But if you own the CE, you can kind of get away with doing this, right? So what technology is it called? It is called Get VPN. So Get VPN, and this stands for Group Encryption Transport VPN. That's what it stands for. So basically what that does is it's going to involve a couple of things. Obviously, CEs are going to be involved. Then there's this thing called key servers. And then obviously MPLS is going to be involved in this, right? So how does that look? Well, from a 10,000 foot view, let's say we have the MPLS cloud again. So MPLS is going to be here, right? And then we have a couple CEs. CE, CE. Now behind one of these CEs, and we'll have another CE here, right? But behind one of these CEs are going to be this thing called key servers. Now, for single point of failure purposes, we want to do redundancy, so we're going to have two, and you can't do redundant key servers. And what that key server is responsible for is something called a TEC, which is traffic encryption key, a KEC, which is key encryption key, then is the instancing traffic, instant IT, which is instancing traffic, and then the public key of the key servers. You get these four things when you do Get VPN. So how does that work in the long term? So each one of these CEs, you got to make sure the internal or the external facing interface is also known. So you're going to have to advertise these links here. These links need to be advertised so that so the key server knows how to get back. So what ends up happening is they will do the following, which is when they do crypto, instead of crypto IPsec, it'll be crypto GDOI, right? So that's going to be ultimately what you're configuring on each router is crypto GDOI. Then you need an identity number, an ID number, and then you need the address of the servers, of the key servers of KS, right? And then what ends up happening is each one of these devices, even the one that's behind the key server, will reach out to the key server and get all the information. It will get the instancing traffic, which is usually going to be classless boundary, which is going to be like a major boundary. So 192.168.0.0.0.0.255.235 to 192.168.0.0.255.225, right? Or 0.0.255. And that's really based on what is behind all these CEs from a subnetting perspective. Now, what ends up happening is anytime that traffic wants to go to either location, it will be encrypted in a ISP packet. Obviously, phase ones will happen here, right? Phase ones and twos will happen here. And then all that traffic will be encapsulated in a ESP packet, right? You won't be able to see it in clear text like you used to do before when you were looking at just normal MPLS clear text traffic. Now, the attack vector here is key server. You lose this, all of this basically goes away, right? Because you need this key server to do rekeys. They send out these rekey messages, and it's signed with the private key of the key servers, right? And then each of these CEs use the public key that they downloaded from the key servers to validate those rekey messages. All right. To validate the rekey messages. If you lose the key server, you pretty much lose the ability to validate the rekeying messages, and then this whole thing falls down, Now, again, if you own the CEs, you're going to be able to have your own key servers and then be able to do this by yourself. If not, you're going to need the service provider to actually do this for you. And then they're going to have to protect their key servers from being attacked. So that's how you secure MPLS in a nutshell. And it answers the question, is MPLS secure by default? The answer is no, but there is a way to protect it using GetVPN. Once again, this is Donald from Panlock Technologies. Hopefully this video was informative. Thank you and have a nice day.